Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to talk about arithmetic series, the finite sum of a finite arithmetic sequence. So if we know the first term a sub 1, the common difference d, and the general term a sub n, we can use this formula, n over 2 times a sub 1 plus a sub n, that quantity. So we're going to start off with kind of a classic problem, find the sum of the first 100 positive integers. So if we think about this, we can see that d is equal to 1. We know that a sub 1 is equal to the first number, also 1. And we know for the first 100, a sub 100 is 100. So if we want to find that 100th sum, actually, let me write it in a different space. I want that space for something else in a minute. S sub 100 is equal to 100 divided by 2 times a sub 1 plus a sub n. 100, we end up with basically 100 times 101 over 2. And if I divide 2 into 100, that's 50. And if I multiply that out, I get 5,050. So that's the sum of the first 100 numbers. The reason I said this is kind of a classic problem is this is a problem that was solved by the great mathematician Gauss. When he was roughly in the 3rd grade, he had a teacher who told him to, he gave him some busy work, add up the numbers from 1 to 100. So you get your slate out and your chalk and all that. And Gauss immediately said, well, that's 5,050. And, the teacher was a little upset because his plan to sideline the student didn't work. But here's a little bit about how Gauss did that in his head in the 3rd grade, a long time ago. If we think about that sequence again, 1, 2, 3, ... 98, 99, 100. What Gauss did was the following. If we take the two numbers at the end, 1 and 100, and add them together, that adds up to be 101. If we move in one step and we take the next two numbers, 2 and 99, that also adds up to be 101 because we're adding 1 to the bottom number but subtracting 1 from the top number. And so he noticed that these sums were all going to be the same. Adding two numbers from outside in, you get a sum of 101. Then the question is, how many of them are there? There are 50, because if you break 100 in half, that's 50 pairs of numbers. So he knew that there were 50 101s, and then it was a simple multiplication problem from there. Anyway, back to our issues, not his. Find the sum of the first 15 odd positive integers. So the first one is 1, 3, 5, and I'm not going to list them all out. I'm going to come up with a formula to list them out, because if that 15 was 315, I definitely don't want to list 315 numbers. So we'll go over the way that we do that. What I do notice is that the difference is 2. And again, we know that a sub 1 is 1. The formula for the general term of an arithmetic sequence, again, is a sub 1 plus n minus 1 times d. Here, that's going to be 1 plus n minus 1 times 2. And if we're looking for the 15th term, a sub 15 is 1 plus 15 minus 1 times 2, which is 1 plus 14 times 2. 14 times 2 is 28, so the last term is 29. Now we can go to the formula for the sum. S sub 15 is equal to, right, we're going to use that same formula from above. It's going to be 15 over 2 times the sum of the first one plus the last one. Now this time, 2 doesn't divide into 15, but if we write this as a single fraction, we will see that 2 does divide into 30. Right? And 2 into 30 goes 15 times. 15 times 15 is 225. So the sum of the first 15 odd integers is 225, which happens to be 15 squared. Coincidence? I don't think so. Next problem. Find S sub 15 for the sequence -13, -5, 3, 11, and so on. We can see that the difference is 8 for each term, so it's an arithmetic sequence. We know that A1 is equal to -13. We know that D is equal to 8. The formula for S sub 15 is 15 over 2 times A sub 1 plus A sub n. However, we don't know A sub n yet, but we can get that. I'm sorry, it shouldn't be A sub n. That should be A sub 15, which we can get from A sub n, which we can get from A1 and D. A sub n, again, is A sub 1 plus n minus 1 times D. So A sub 15 equals -13, that's my value of A sub 1, plus 15 minus 1 times 8, that's my value of D. -13 plus 14 times 8, -13 plus 112, which is 99. So coming back to the summation formula, 15 over 2 times -13 plus 99. That becomes 15 times 86 over 2, which we can reduce, but my 15 times 43, I'm not that good at that. So I'm going to show you 15 times 86 divided by 2, and then we'll take a look at 15 times 43. Fraction 15 times 86 over 2, that's 645. We could also have done 15 times 43, also 645. Now, for the last one, I made a couple of typos here that'll be fixed by the time you see this document. What it says is, if the sum of the first 20 terms of an arithmetic sequence is 3,600, and we know that A sub 20 equals 351, find A sub 1 and D. So first thing we're going to do is try to find A sub 1. Summarizing the information that we have, we know that S sub 20 equals 3,600. And we know that A sub 20 equals 351. And finally, we know that the formula S sub n is n over 2 times A sub 1 plus A sub n for an arithmetic series. So in this case, n is 20. S sub 20 equals 20 over 2 times A sub 1 plus 351. And S sub 20, we also were told, is 3,600. So putting that on the left-hand side, 20 divided by 2 I can do, that's 10, times A sub 1 plus 351. Divide out the 10 from both sides. 360 equals A plus 351. And when we subtract 351 from both sides, we find that A sub 1 is 9. Now, to get the common difference, we'll use this formula. A sub n equals A sub 1 plus n minus 1 times D. And I'm going to use n being 20 because I have some information about A sub 20. A sub 20 will equal A sub 1 plus 20 minus 1 times D. I know A sub 20 is 351. I know A sub 1 is 9. 20 minus 1 is 19. So 351 equals 9 plus 19D. Subtract over the 9. 342 equals 19D. And when we divide by 19 on both sides, we get D equals 18. So A sub 1 equals 9, D equals 18 for this sequence. All right, that's it for this one. I'll see you in the next video.